This is the second video about this formative assessment that we did this week called Solving Exponential and Logarithmic Functions. And I'm going to focus on this in this video on these four problems, numbers 5 through 8, which the directions say to solve each equation for x by rewriting it with a constant base. Use the laws of exponents when necessary and show all steps. And so what I mean by rewriting it with a constant base, maybe that's not the best direction, but my expectation is that you rewrite this equation so that you have the same base on both sides. And let's just see how that works out for us here in this first problem. Again, 81, you see a base of 3 over here. And so my first instinct is to try to imagine if I can write 81 as a power of 3. And we've done some work on our powers of 3, so I hope you know that 81 is just 3 to the 4th power. And if you don't, you just have to start playing around with it. 9 times 9 is 81. And 3 times 3 is equal to 9. So if I multiply 2 9s, it's the same as multiplying 4 3s. And if you have any concern about that, just sit and do the multiplication. Take whatever 20 seconds it is required to just double check that you've got the right power of 3 here. On this side, I'm just going to copy my left-hand side right there. So now I have 3 to the power of x plus 5 equals 3 to the power of 4. Well, if my bases are the same, then my exponents also must be the same. So the next step, I can just write this. X plus 5 equals 4. This exponent has to be the same as this exponent. And then again, I can use the properties of equality now to solve this very simple linear equation. If I subtract 5 from both sides, I get x equals -1. And that's my solution. And before I move on, I'll just confirm if I put it back up here, I get -1 plus 5, that's 4. 3 to the 4th power is 81, which is what I expect from this side of the equation, that it equals 81. So I like my solution here, and I've shown a collection of intermediate steps to satisfy the directions. Now, they do get a little more challenging. This one here, though, notice we're also dealing with powers of 3. This is 3 to the -1st power. That's how you get 1/3. And 9, of course, is 3 squared. So let me just rewrite both sides of this equation now. First, I will write my 1/3 like that, and I'll raise that to the x plus 1 power. And on the right-hand side, 3 to the 2nd power. So I'm almost there. I would like to get rid of these parentheses, so it's a good opportunity to use the power rule. If I raise a base to a power and then to another power, I can take the product of those exponents and rewrite this as, and I have to use the distributive property here. It's -1 times x plus -1 times 1, which leaves me with a -x minus 1. And that equals 3 squared. So now it's very much like the first problem. I have the same base, 3, on both sides. And because the bases are the same, the exponents also must be the same. -x minus 1 has got to equal 2. And this is a nice linear equation that I can solve using the properties of equality. Adding 1 to both sides gives me -x equals 3. And then taking the opposite of both sides, or if you like, multiplying both sides by -1, changes my -x to a positive x and my positive 3 to a -3. And there's my solution. Again, I can plug -3 in to my original equation and just make sure that I got the right answer. -3 plus 1, that's -2. And so if I raise 1/3 to the -2nd power, that's the same thing as raising 3 to the +2nd power, which of course gives me 9. So I have to do a little thinking in order to confirm that my value of x is correct, but it is. Now, this one, we did see an example like this on our problem set that covered this material, and I know that our Khan Academy assignments also dealt with how we handle radicals, like the square root symbol here, in our exponential equations. And that's where I'm going to start, is just remembering that when I take the square root of a number, it's the same thing as raising it to the 1/2 power. So if I were to use that information, my problem becomes 27 to the 1/2 power raised to the power of x. So I can continue by using my power rule here, and I know that this should be 27 to the power of x over 2. I just multiply my exponents here. The next thing to notice is, and once again, just following the directions, is we want to rewrite both sides of this equation so that they have the same base. And I notice that 9 and 27 are both powers of 3. So I will say not 3 to the second power on the left-hand side, and that's the same as 3 to the third power. That's my 27. And I'm going to raise that to the x over 2. And now I have to use the power rule once again to say that 3 squared equals 3 to the 3x over 2. And now my bases are equal, so I can set my exponents equal to each other, multiply both sides by 2, and that gives me 4 equals 3x. Divide both sides by 3, and I get x equals 4/3. And just continuing to the final problem, notice they do get more and more complicated as you move to the right. But I hope you can see in this problem that we have a bunch of bases, 4, 8, and 1/4, that can all be written as powers of 2. So let me just rewrite this whole equation, changing my 4 to a power of 2, 2 to the second power, and leaving my exponent as it is. 8, that's 2 to the third power, and I raise that to the power of x. 1/4 is 2 to the negative second power, and I raise that to the power of 1 plus x. So now I got a whole bunch of laws of exponents that I need to employ here in order to reach a solution. Remember, I'd like to have 2 exponential expressions, one on each side of this equation, with the same base. So, power rule, and in this case you have to use the distributive property. This becomes 2 to the 2x plus 4, and this becomes 2 to the 3x, and this becomes, again using the distributive property, 2 to the negative 2 minus 2x. On the right-hand side now I have a product of powers of 2, and I can combine those together by adding the exponents. So my left-hand side stays the same, and my right-hand side is 2 to the 3x minus 2x, that just leaves me with x, and then I'm subtracting 2. So all I did was I added these exponents together in order to combine these exponential expressions, this product of exponential expressions, into one. So now that the bases are equal, the exponents also must be equal. And my video is running out of time, so I want to show you, I'm going to skip some of the properties of equality here, and just, if I subtract the x to this side, I'm left with an x. And if I subtract 4 to this side, my answer is x equals negative 6. And I will leave it as an exercise for you to confirm that this value of x makes this equation true.